June 1940. A dusty road near Reading, Berkshire. British Army engineers pour concrete into wooden moulds whilst German bombers thunder overhead. Within 72 hours, this hexagonal structure would become operational. 1 month later, military planners estimated it would take German panzer divisions 3 weeks minimum to breach what they were building. The GHQ line had transformed Britain into a fortress, and these simple concrete pillboxes were the reason why. Most historians believe Britain stood defenseless after Dunkirk. They would be wrong. Between May and October 1940, Britain constructed the most ambitious defensive network in military history. Over 28,000 hardened concrete positions appeared across the countryside. The centerpiece was the General Headquarters Line, an 800-mile barrier of reinforced concrete stretching from Somerset to Edinburgh. General Edmund Ironside, Commander-in-Chief of Home Forces, oversaw this colossal undertaking. His engineers had a brutal problem: stop German armored divisions with virtually no tanks, no anti-tank guns, and no time. The solution was deceptively simple: concrete. But what made these structures so effective that German intelligence files classified the GHQ line as Britain's primary defensive capability? The pillbox program began on 27 May 1940. Major General G.B.O. Taylor established the Directorate of Fortifications and Works, designated FW3. His team had one objective: design pillboxes that ordinary laborers could construct in days using minimal materials. By July, FW3 had issued 6 basic designs, designated Type 22 through Type 27. Each served a specific tactical purpose. The Type 22 was a regular hexagon, 6 feet per wall, with rifle embrasures in 5 faces and an entrance in the 6th. Wall thickness varied from 12 inches for bulletproof protection to 40 inches for shell-proof variants. Internal measurements between opposite walls measured approximately 10 feet. The Type 24 proved most common, an irregular hexagon with the rear wall extending 14 feet to accommodate the entrance plus 2 rifle embrasures. Other walls measured 7 to 8 feet, each housing a single embrasure. A Y-shaped anti-ricochet wall inside supported the roof whilst protecting defenders from grenades. The Type 28 represented Britain's main anti-tank defense. Nearly square in plan, measuring 20 by 19 feet, with walls 42 inches thick. The forward-facing embrasure was enormous, designed for the Ordnance QF 2-pounder anti-tank gun or the Hotchkiss 6-pounder. The gun shield filled the aperture, protecting the crew whilst limiting traverse to approximately 60 degrees. This wasn't a weakness. The Type 28 was positioned to fire along fixed lines, enfilading fire across anti-tank ditches, covering bridges, defending canal crossings. The limited traverse became an advantage. Smaller aperture meant better protection. German tank tactics relied on speed and breakthrough. Their doctrine assumed enemy defenses would collapse under concentrated armored assault. The Blitzkrieg had worked in Poland, France, and the Low Countries because defensive lines could be bypassed or penetrated. The GHQ line eliminated this possibility. If you're finding this deep dive into British defensive engineering interesting, subscribing helps ensure you don't miss the next one. The concrete specifications told the real story. Shell-proof pillboxes used walls between 36 and 50 inches thick. General Alan Brooke conducted penetration trials in March 1940. A German 25mm anti-tank gun could penetrate 2 feet of reinforced concrete. Therefore, shell-proof variants required minimum thickness of 3 feet. The concrete mixture used conventional thin steel rebars, with floor, walls and roof mutually bonded. In coastal positions, builders used beach sand and pebbles. Near quarries, local stone mixed with the cement. This wasn't just expedience. Different aggregate densities affected projectile penetration rates. Beach pebble concrete proved remarkably resistant to armor-piercing rounds. Construction methods varied based on available materials. Brick shuttering formed molds for concrete pouring, the bricks remaining in place. Wood shuttering, usually planks but sometimes plywood, was removed after curing. Corrugated iron shuttering sometimes stayed embedded in the structure. Where materials were scarce, builders improvised. Some pillboxes incorporated bed frames as reinforcement. Others used park railings requisitioned from London squares. The defensive network operated on 3 layers. Coastal crust positions at vulnerable beaches provided initial resistance. Stop lines running inland along natural barriers, rivers, canals, escarpments, compartmentalized invasion forces. The GHQ line formed the final barrier, protecting London and the industrial Midlands. Between Great Chesterford and Canvey Island in Essex, 400 FW3 pillboxes formed an interlocking defensive zone. Each Type 22 covered the approaches to its neighbours. Type 28 gun emplacements provided overlapping fields of fire. Infantry positions filled the gaps. German intelligence officers studying aerial reconnaissance photographs identified the GHQ line's true strength. Unlike the Maginot Line or Siegfried Line, which concentrated firepower in massive fortifications separated by gaps, the British system dispersed defensive positions. No gaps existed. Every approach was covered. More critically, the pillboxes were dug in, camouflaged and mutually supporting. Destroying one position wouldn't create a breakthrough. Panzers attempting to advance would face fire from multiple directions whilst channeled into killing zones by anti-tank obstacles. The effectiveness calculation was straightforward. A German panzer division advancing cross-country could cover 20 miles daily in open terrain. Against the GHQ line, engineers estimated 3 to 4 days per mile. The mathematics were devastating. 800 miles of defense meant German forces required 2 years to break through, assuming continuous combat with no resupply issues, no casualties, and no British counterattacks. Testing revealed additional tactical advantages. The Type 22's hexagonal shape provided wider fields of fire than square designs. The Y-shaped internal wall prevented ricochet injuries whilst creating separate firing positions. Embrasures were deliberately small, large enough for rifle barrels or light machine guns, too small for enemy grenades. German stick grenades measured 12 inches long. British embrasures averaged 6 inches wide. The standard infantry section of 8 men could defend a Type 22 indefinitely against infantry assault. Against armor, defenders would withdraw through communication trenches to Type 28 positions where 2-pounder guns waited. Production reached industrial scale. Local contractors built pillboxes to FW3 specifications. Stent Precast Concrete Limited produced prefabricated Type 26 components, precast concrete slabs slotted into reinforced posts filled with concrete in situ. 20 workers could complete a Type 26 in 18 hours. W.E. Chivers constructed the pillboxes along the Kennet and Avon Canal section of the GHQ line. Molam contractors built Type 24 variants using circular external shuttering, creating the distinctive Molam drums found along the River Wey in Surrey.
Camouflage techniques proved remarkably sophisticated. Artists, including Roland Penrose, author of the Home Guard Manual of Camouflage, supervised concealment operations. Pillboxes were disguised as haystacks, cottages, signal boxes, even Romany caravans. One position near Trafalgar Square was built inside a tourist information booth. Another, in Brighton, formed part of a seafront sweet shop. 6 pillboxes along the Taunton stop line were coated with cow manure and mud, topped with straw. Coastal positions used camouflage paint schemes matched to local terrain. Hooks welded to roof slabs supported camouflage netting. The concrete roof on some structures was sculpted to eliminate the distinctive pillbox silhouette visible from the air.
German planning documents captured after the war revealed Operation Sea Lion's fundamental problem. Wehrmacht planners estimated 14 days to reach London from invasion beaches, assuming light resistance. Intelligence reports on the GHQ line forced revision. New estimates suggested 6 weeks minimum, requiring complete destruction of defensive positions. Luftwaffe bombing couldn't achieve this. The pillboxes were too dispersed, too well concealed, too heavily protected. Strategic bombing doctrine focused on destroying enemy industry and morale, not individual fortifications. Tactical air support couldn't eliminate hundreds of pillboxes whilst supporting ground operations. By February 1941, General Headquarters issued orders. No more pillboxes were to be constructed. 28,000 hardened field defenses were complete. Production ceased not because the system failed, but because it succeeded. Mobile reserves were now available. The invasion threat had passed, but the concrete remained. Over 6,500 pillboxes survive today. Type 24 is most common, with 1,724 recorded extant. Type 22 follows, with 1,347 examples. Type 28 and variants total 306. The Essex section of the GHQ line between Rettendon Turnpike and Howe Green preserves 40 highly visible examples alongside the A130 road. Surrey's GHQ line retains substantial sections with complete defensive networks intact. The Mowlem drums along the River Wey between Godalming and Albury remain virtually unchanged since 1940. These concrete structures never fired a shot in anger. Operation Sea Lion was postponed indefinitely in September 1940. But military historians agree the GHQ line was Britain's most effective defensive weapon. Not because it destroyed German forces, but because it made invasion impossible. The mathematics couldn't be solved. No breakthrough was achievable. The concrete wall that stopped an entire invasion existed not as a single barrier, but as 28,000 interlocking positions that transformed Britain into an unbreakable fortress. German planning staff reached this conclusion by August 1940. The concrete pillboxes built in 72-hour shifts had accomplished what armies and navies could not. They had made Britain impregnable.